Hey guys, it's Elton here with you. I'm going to help you solve an inequality today and then graph it on the number line. Now these problems are called compound inequalities because they have more than one part. There's this first part, if you sort of ignored this less than 5 over here, that's just like a regular old inequality. And vice versa, you could cover up the less than negative 1 and here's an inequality over there. So there's sort of two inequalities in one. And we're going to solve it sort of like two separate inequalities and graph them like two separate inequalities. So I'm going to solve this first one just like I would any old inequality, just like an equation really. I want to isolate the variable. I do that by subtracting 1 from each side. I'll get negative 2 is less than or equal to 2c. And the important thing to keep in mind, this sign will always just stay the same, just like an equal sign would. Unless, of course, you happen to divide by a negative or multiply by a negative. Now, in this case, did I divide by a negative number? I realize there's a negative number over here, but is that what's being divided? The answer is no. Positive 2 is being divided. And for that reason, our inequality stays the same, and I end up with this negative 1 is less than or equal to c. Great. That was, again, that inequality right there. Now, I'm going to take this second part and solve it in blue beneath, and it's going to work just the same way, and I'll graph both of these on the same number line in just a second. Now in this case, it works the same way. We're actually going to do the same two steps. We're going to minus 1 and divide by 2, and just like last time, I'm going to end up with the same sign. Oops, not 2. Because of course I'm not dividing by a negative, I'm dividing by a positive, so the sign stays the same, and I get c is less than 2. So I end up with these two different inequalities, and I'm just going to graph both of them on the same number line, and that's it. So this first one, you always take the number on the inequality sign, and that's where you put your dot. So at negative 1, I'm going to put a dot, and this tells me, the underline tells me that it's going to be filled in. It's going to be a solid dot because we're including that point as a possible solution to the inequality. C could be negative 1 because negative 1 is indeed less than or equal to itself. And for that reason, we color it in, and that just tells us, yeah, that works. As well as everything that is greater than negative 1 because C is on the gator side. So for that reason, this is going to be pointing to the right. And I make an arrow. On the flip side, C is less than 2. I need to go to 2 on my number line. And this time I'm going to have an open circle. And since it's less, it's going to be pointing to the left. Now, a lot of people get tripped up over this. The reality is, since I have two arrows pointing in the opposite direction, they sort of overlap each other. Sort of end up getting this funky thing. So instead of just leaving them as two separate things, I'm actually going to erase what I have here, and I'm going to combine them into one complete inequality. How do I do that? Well, I'm going to start at negative 1. It is solid and filled in. The arrow is going to the right, and then that's going to stop at 2, where I have that open dot, and this just tells me that all the points between negative 1 and 2, not including 2, work for both of these inequalities, or the compound inequality. So there you have it. Hopefully that helps you. If you need any more help on this, please be sure to email me or let me know.